P is the multiple of 2 and Q is also the multiple of 2. But we have already taken this P and Q as a prime number. So there is only 2 factors. Now we are getting one more factor, which is 2. Other than P and Q, we are also having one more factor, which is 2, which cannot be possible for the prime number to having more than 2 factors. So this statement or our assumption is false. So root 2 is the irrational number. So root 2 is the irrational number. Let me explain once again. We have to prove that root n as an irrational number. Here, root 2, we have assumed that this is a rational number, means it can be represented as P by Q form. We have assumed that this P and Q are the prime numbers, means prime numbers means there will be only 2 factors, the number itself and the 1. Now, squaring both the sides, will be getting root 2 get squared into the form of 2. Here P square by Q square, this Q square will go over here. So it will be 2 times of Q square is equal to P square. Now, as we can see, this P square is equal to the 2 times of Q square. So it is the multiple of 2. So P will also be the multiple of 2. Now, we are seeing that in the left hand side 2Q square. So 2Q square is the even number. So Q will also be the even number. And Q will be the even number, then it will be the multiple of 2. Now we are getting the P and Q as a multiple of 2. And the itself factor will be P and Q and 1, because prime number is the number which is having the factor of number itself and the 1. So there are more than 2 factors we are getting over here. So our assumption is false. So this number is not a rational number, it's a irrational number. Now let us move to the next topic, representing the irrational number on the number line. Representing irrational number on number line. Let us take an example of root 9.3. Now we have to draw this on the number line. First, you have to put an scale and measure it to the 9.3. Suppose we are getting these 2 points. Now joining these 2 points, this is A, this is B, this is 9.3. Now you have to increase this length to the 1 centimeter more after this B. So increasing this till C. So this is 1 more centimeter. So total it will be 9 plus 1 will be 10.3 centimeter. Now with your compass you have to open more than half and put the needle over here at point A, and you have to cut one arc right up, one arc right down. From point C you have to cut an arc up, cut an arc down, and joining these 2 points. So you will be getting one midpoint as O over here. Now keeping the needle over here and measuring it A, draw a semicircle. So you will be getting like this. You will be getting semicircle like this. Now you have to put the scale on point B and draw one perpendicular intersecting at point D. Drawing one perpendicular over here, we are getting point D. Okay. Now from here you have to draw an arc. From point B measuring BD, you have to draw an arc. When you will draw an arc, this will get intersect this line at point E. Now this BE is your root over 9.3. This BE is under root of 9.3. Let me explain you once again. First of all, you have to draw a line of 9.3. Whatever number it is given in this under root, you have to draw that line as AB. After that, from point B, you have to extend it till 1 centimeter till point C. After that, you have to open your compass measuring more than half at point A. You have to cut 2 arcs over here and below this, and from point B and from point C you have to cut one more arc over here. So you will be getting 0 as the center. From point O you have to make one semicircle and draw one perpendicular from point B to this semicircle which is intersecting at point D. Now you have to take BD as the radius and draw an arc which is intersecting at point E. Now measure this BE, it will be under root of 9.3 or whatever number you want. So I hope you got how you have to make this number. Now let's move to the other topic, exponents. Exponents are generally written in the numbers with the power. You have seen earlier also in earlier classes. The terms which are represented with the power are generally called as exponent. So our topic is exponents. Suppose we are having the number 1 to the power 2 or x to the power 4 or y to the power 3 and so on, a square, b cube and so on. All these terms are generally the form of exponents. Now how we have to solve this with addition, multiplication and division? Let us see. Here some laws of the exponents we have to go through. First is, if we are having the same base, here 1 is base, x is base, y is base, and these powers are generally the exponents. 2 is the exponent, 4 is the exponent, 3 is the exponent, 2, here 3 is the exponent. And these, the numbers which are, or the alphabets which are written below are called the base. If we are having the same base, means a to the power m, which is multiplied with a to the power n. Here base are same and the exponent or the power are different. So we can directly write it as a to the power m plus n when there is a multiplication sign in between them. Now next, a to the power m divided by a to the power n. Here base is same and power is different, and we are having the division in between them. So they can directly be written as a to the power m minus n. If there is a division, there will be the minus n between the m and n. Now third property, a to the power m whole to the power n. So the base is a and the power to the power m and n. So it will be a to the power m multiplied by n. Now let us take the another example, a to the power m plus a to the power n. So you have to solve it separately. Let us see how we will be solving this in the next example. So 1, 2, 3, 4, these are the laws of the exponent. One more law is there. If we are having a to the power minus m, this minus sign with the m represent can be also be represented as 1 upon a to the power m. This number will be getting reciprocal or in the denominator. So we will be getting 1 upon a to the power m. Now let us see how we are solving this with the laws of exponent. Here we are having 2 to the power 4 into 2 to the power 5. Either you can write 2 into 2 into 2 4 times, into 2 into 2 into 2 5 times and solve it, or by the law of the exponent we can solve it as 2. This is base are same and power are different, and this is the multiplication sign. So 2 to the power 4 plus 5, because if there is a multiplication sign, there will be the plus sign in the power. So it will be 2 to the power 4 plus 5 will be 9. So it will be 2 to the power 9, and you can further solve it if you want. Second, let us take the example of 2 to the power 4 divided by 2 to the power 5. Now we are having the division in between them. We are having the base same and power different. So it will be 2 to the power 4 minus 5. This 5 will go upside. So it will be minus because there is a division between them. So it will be 2 to the power minus 1. And it can also be further written as 1 by 2. Because minus sign with something in the power will make it in the reciprocal form. Now let us see one more example. 5 to the power minus 1 or 5 to the power minus 1 can also be written as 1 by 5. Okay. So these are the examples how we can solve the exponents. Now let us move to the other part, rationalization. Rationalization. As you have seen, this root 2, root 3 and all these kind of numbers which are under the root are the irrational numbers. Now if these irrational numbers come in the denominator, then how we are going to solve them? Suppose we are getting 1 by root 2 or 1 by root 3, or suppose we are getting 1 upon 2 plus root 3. So we are getting the irrational number in the denominator. For these kind of numbers, we have to do the rationalization. Let us take the example of 1 by root 2. Now here we are having the root 2 in the denominator. For the rationalization, you have to multiply this number in the numerator and in the denominator. So rationalizing this will be root 2. You have to multiply same number in the numerator and in the denominator. So it will be root 2 divided by root 2. So it will be root 2. This will be root 2 into root 2 will be root 2 square. Root 2 square. So it will be root 2 divided by 2. Now we are having the whole number in the denominator. So we converted the irrational number into the whole number in the denominator. Let us see one more example. We are having 1 plus root 3, 1 upon 2 plus root 3. Now we have to rationalize this. For rationalize these type of number, we have to just change the sign which is between these two numbers and multiply and divide the same number in the numerator and the denominator. So it will be 2 plus root 3. We have to change this sign, multiplying 2 minus root 3 by 2 minus root 3. So this will be 1 into 2 will be 2, 1 into minus 1 into root 3 is root 3. Now as we can see here, it is making a form of a plus b, a minus b. So it can be written as a square minus b square. So this will be 2 square minus root 3 square. Now 2 minus root 3 as it is, 2 minus root 3 as it is. This 2 square will be 4 minus this root 3 square. This root 3 square will be 3. Further solving this, 2 minus root 3 and this will be 4 minus 3, 1. So 2 minus root 3 is the solution for the given rationalization. I hope you like the topic of the day, and if there is any query, you can ask me in the comments below. Thank you.